Hi everyone, welcome back to another lecture of DBMS. And in this lecture, we will learn about what is closure in functional dependencies, importance of closure. Then we'll see what are the methods to compute closure of a set. Then we'll learn about two different types to find the closure, which is iterative application and of Armstrong and attribute closure approach. So we will be learning about these things about closure. So again, this video is again going to be very much important. So stay tuned and let's begin with the very first topic, which is what is closure in functional dependencies. So we know that closure is a set of functional dependencies, right? So and it if we denote the functional dependencies by F, then closure of functional dependency, we will denote it by F with the plus sign. It includes all the functional dependencies that can be inferred or derived from the initial set of functional dependencies using the inference rules. So basically we have learned about inference rule with the help of whatever we have functional dependencies here, like let's suppose A defines B and B defines C. So we can say A directly defines C, right? So with the transitive rule we have find out this. So with the inference rule we find out this, and now if we will add this also in the same functional dependency, so we will denote it by F plus, and this will be called as the closure of that set, right? So the new dependencies are discovered by applying series of inference rule like reflexivity, augmentation, transitivity, etc. to the original dependency. So with here is example, A defines B and B defines C. We can say with the transitivity A defines C, and now the closure will be A defines B, which was already there, A defines C, which we have find out with the transitive property, A defines D, which is already there, and B defines C, which is already there, right? So this will be called as, instead of F, this will be called as F plus, and these are the proper set of functional dependencies, the previous one and the new derived ones also. So this will be called as a closure in a functional dependencies. Now, why closure is so important? So we know that when we are having the complex functional dependencies, so to simplify it, we break down sometimes, and sometimes we include it, right? Combine it also. Why we are doing? So that in the normalization method, it will be easy for us to find out the relation between the different tables. So closure is critical in database because it allows database designer to detect implied dependencies and ensure the database schema enforces all necessary constraints. Without computing the closure, some hidden dependencies might be missed, so leading to potential data anomalies or redundancy. So if you will not closure means if you are not finding out the new derived functional dependencies, then it might happen that some of the relation was there but you missed it, right? If you can say that let's take that previous one, transitivity one. So we know that with the help of transitivity we can say A has direct relation with C, but if we are not finding it out, then we are stuck in some loop that A determines B, then B determines C, and what is the number of table is so large, the number of column is so large, right? So instead of directly finding out the C from A, we are finding out B from A, then again C from B, right? So this is what, if we are not doing so it might happen that it can lead to potential data anomalies or duplicate values also. So in IRCTC example, let's suppose we have following functional dependencies where we are saying train ID defines date. So here train ID in the booking table defines date. Okay. Now date defines passenger. So date defines passenger. So this says date defines passenger. Okay. Now the closure of functional dependencies will include train ID defines passenger. That is because of the transitivity, because we have we said ki train ID defines date and date defines passenger. So it is X determines Y determines Z. So we can say train ID directly determines passenger, right? So this we can say that we can infer, we can derive the new functional dependency with the previous ones with the transitivity. So that is why closure is so much important to simplify the functional dependencies, so that we can avoid data anomalies or redundancy in our table during the normalization. Now let's see what are the two different methods to compute closures in a set. First one is iterative application of Armstrong axioms. So basically here what we do, we apply Armstrong axioms rules, basically inference rules like reflexivity, transitivity, decomposition, and all 7 different types of rules which we have learned already in past lecture. If you have missed, I would request you to go learn that first, then only come to this lecture. So applying those 7 rules, if you are finding out the new functional dependency and keeping it in that set of functional dependency, so that is called the iterative application of Armstrong axioms to find the closure. Okay, so this is nothing but step-by-step derivation of new functional dependency from existing one using those rules. So how we do? First, we start with the known dependencies, because whatever functional dependencies have been given, we will first verify it. Then we will see to which functional dependency we can apply those rules, and then we will find out the new functional dependency until all the new functional dependencies are derived, and we can say that those are the set of functional dependencies. Another method is attribute closure approach. So in this, we are not going to apply any kind of inference rule or Armstrong axioms rules. So in this, what we can do, directly compute the closure of a set of attributes by determining all attributes that can be functionally determined. So how we basically do? First, let's suppose we have A. So we know that every attribute determines itself, right? So we will say A. Now, what we will do, we will try adding B here, and we'll see if they are following this rule or not. Yes, if they are following, we can say this is one of the functional dependency. If not, then we will try with A determines C. If they are following or not, then we'll determine another one. So this is how we actually do. In this, iteratively, we are adding the attributes to the closure until no more can be added using the functional dependencies, right? So what we do, first we start with a set of attributes. We focus on that, and then for each attribute, we check if new attributes can be added by functional dependency or not, and then we will continue until no attribute can be added. So in this, one by one, we check and see if that is being followed in the table or not, and then accordingly we try to find out the new functional dependencies. So these are the two different methods to compute the closure in the functional dependencies. And yeah, that was all about this closure methods. Now let's try to understand with the given example. So let's see in the iterative application of Armstrong's axioms. So what we do here, we first simply apply the Armstrong axioms to a set of functional dependency. So let's say train ID determines the date and date determines passenger. So here we will apply the transitivity rule, and we can say that train ID directly determines passenger. Okay. So here first what we will do, train ID determines date. So this is a reflexivity. So here we will say the result is train ID determines date. Similarly, second, also transitivity, train ID determines second one is this, right? Date passenger. So we will find out the relation, right? After reading the second dependency, and we can say if we'll apply the transitivity, we can find out the new relation, that is train ID passenger. So now the final closure, we can say that train ID can find out date also and passenger also. So this will be our final closure for the functional dependency with the help of Armstrong axioms rules. Now, second one is attribute closure approach. So let's see how we do here. So we have to, again, the same functional dependencies we are having, and how we are finding out the new functional dependency without following any rules. First, we will check the train ID, and then we'll see as train ID can find out train ID, right? So now we'll check here. Do we have some relation with train ID? So yes, we have that train ID can find out date. Okay. Then we will mix that. We will we'll put date, and then we'll find if that can form any functional dependency. Yes. So we will say that functional dependency 1 relies on this. So we can say that train ID will find out date. Now we have date. Now we can say ki now train ID date is related. Now we will add passenger here, and we'll check if date or train ID or passenger have some relation. So from functional dependency 2, we can say yes, date can determine a passenger. So here, since date is already known to us, these are already known to us, right, from the second step. So we can find out the passenger with the second one, and we will say yes. Now the closure will be train ID, date, and passenger, and in this way we can find out the closure of the functional dependency with the attribute closure approach, where we are not following any inference rules. So these were the two different types of methods to find out the closure. And what we have learned in this lecture, we have learned about closure, why it is so important, and what are the two different methods to find out the closure of a functional dependency. That was all about the whole lecture. I hope you understood and learned. I tried my best to explain you both the things very well. So now let's meet in another lecture. Till then, keep learning. Take care of yourself and your family too.